Hey guys, you've been introduced to the idea of valence electrons. We're just going to take a few notes to make sure you know all about them and the trends in the periodic table that you need to know about them. So we call valence electrons, we call this activity life on the edge because valence electrons, as you may have already learned, are kind of living on the edge of an atom, right? So valence electrons are electrons that are located on the outermost electron shell of an atom. For example, right here I see a Bohr model of sodium. How many electrons are located on the outermost electron shell of that atom? Let's look at the biggest ring around the atom, right? And you see one. So the sodium atom has one valence electron. On the other hand, let's see, we look at neon right here. Neon has two electrons in the first one, of course, and here's your outermost one. So it has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons on the outermost ring. So it has 8 valence electrons. All you have to do to figure out valence electrons when you're looking in the Bohr model is count how many electrons are on that outermost ring. Pretty simple. Why are they so important? So the number of valence electrons that an element has determines how it will react. You don't need to know how this works yet. We're going to learn about that in the next unit. So just be aware, these valence electrons, the reason we learn about them is because they're really important to determining how atoms react with each other. You guys already saw this periodic table, but if we were to draw Bohr models of the first 18 elements in the periodic table, they'd be lined up on the periodic table like this. And the obvious trend you're going to notice is that every atom in this first group, all the alkali metals, all have one valence electron. Every atom in the alkaline earth metals, group 2, has 2 valence electrons. Every element in group 13 has 3 valence electrons, 4, 5, 6, 7. Almost everyone in this group has an 8 except for helium. Remember, helium's our awkward guy up there. It only has 2. So the trend that we're trying to illustrate can be kind of summarized like this. If you're trying to figure out how many valence electrons an element has, you don't need to draw the Bohr model of the element if you don't want to. And the quicker way to figure out how many valence electrons it has is just to know this pattern. Every element here in group 1 has 1 valence electron. Every element in group 2 has 2 valence electrons. Group 13 has 3, 14, 4, 15, 5, 16, 6, 17, 7, 18, 8. You might be wondering, why don't we indicate the number of valence electrons on these transition metals right here? Well, the thing is, these transition metals do not follow the same pattern as the rest of the elements, and it's kind of more complicated how it follows the pattern. So I will never ask you on a test or any assessment to tell me the number of valence electrons of any of these elements because they don't follow the same pattern. So just remember that we're just looking at what are called the main group elements: 1, 2, 13, 3 valence electrons, 14, 4 valence electrons, 15, etc. If you'd like, this is a really important trend you need to know. So if you want to add it in some way to your periodic table, however you want to note it, you're more than welcome to. Basically, another way to put it, guys, if this was not super helpful, if you're trying to figure out the number of valence electrons in an element, you just look at its group number. You have all the group numbers written on your sheet already, right? 1, 2, 13, 14, 15, 16, 17, 18. If there's a 1 at the beginning, you drop the 1, and that tells you how many valence electrons it is. For example, over here, group 13 doesn't have 13 valence electrons. It only has 3. So just drop the 1, and it will tell you how many valence electrons it has. In case you haven't noticed yet, guys, the spokes we talked about on each element at the beginning of this unit represented each element's valence electrons. So you organize the elements at the beginning of the semester, at the beginning of this unit based on their number of valence electrons without even realizing it. We'll be talking much more about these valence electrons and why they matter in the days ahead, so stay tuned. And let Mr. Filsig know if you have any questions.